Hello everyone. The topic today we are going to see is realization of a given Boolean expression using Dynamic CMOS. So there are two types in Dynamic CMOS. One is footed type, another one is unfooted type. So the general diagram for footed logic is it will have a PMOS and a NMOS. A PMOS connected to the source and the NMOS connected to the ground terminal, and in between them we will have the pull down network. That is, it will have a series of NMOS transistors. And whereas coming to the unfooted type, so from the name itself we can say there is no foot in the network. That is, there will be the NMOS transistor will be absent in this particular type. Okay, so now let's design basic logic gate using both footed and unfooted logic. So let us take up an expression. So let me take y equal to a plus b. So this is nothing but a OR gate, right? That is a 2-input OR gate. So let us design it using a simple Dynamic CMOS footed and unfooted logic. Okay, so let's start designing. So first a PMOS, and at the bottom we will have a NMOS, both connected to a common clock input. So and at the middle here we will have the output, that is y equal to a plus b, right? So the connection for a pull down network will be similar to what we have seen in normal static CMOS. That is, if the two circuits are in a that is OR operation, they have to be connected in parallel like this. So that is it, it's over. So this is how you can design a simple OR gate using Dynamic CMOS, that too in footed logic, right? So let us start designing the same using unfooted logic. So as usual we will have a PMOS at the top, so that is it. So this is how you can design a simple Dynamic CMOS, right? So in 2 more questions you may be asked a question. So for a given 4 variable expression, how many transistors will be present in both footed and unfooted type? So first you have to decide a expression for this. So let me take up an expression. For example, let me take up a variable called as n. N will be the number of variables in the expression, right? So then the number of transistors in footed logic. So let me take up so some m variable, right? So m will denote the number of transistors in footed logic, right? So the expressions will be like this, that is n plus 2. So see here, so with this we can easily verify this expression. So the number of transistors is 4, right? So in this expression the number of variables is 2, right? So yeah, that is n value is 2, right? M is equal to n value is 2 and the formula is 2. So the number of transistors is 4, right? So we will have these two transistors as common for any given expression, and the number of transistors in pull down network only will vary. Similarly here we can write it as m equal to n plus 1, and for this one m equal to 2 plus 1 is equal to 3 transistors, right? So this is how the expression goes on, and Thank you for listening. If you have any doubts, post it in your chat box. Thank you.